Okay, so we know now what a wave. We know what have we covered? We know how we see. We know that how we see different colors, and we know what colors are. Colors are down to the wavelength of the light wave. So shorter wavelengths are blue, longer wavelengths are red, and the other colors are the ones in between. And now the next thing is how do we actually use that to convert it into color? Or how are we actually measuring, how are we detecting these different wavelengths of the light? And that's because of these things inside of our eyes called cones. We have rods and cones at the back of our eye, which are doing all the work of detecting the light. And the rods basically they detect all wavelengths of light, really, within our range, that is, and the cones detect more specific ranges. So if we look at this graph, look at this graph here. What this graph is showing is that we have this hump here is showing how well it detects various wavelengths. So when the wavelength is 400, then it detects it medium ability, I suppose, but it prefers this one here, 445 nanometers. So when it's 445 nanometers, this particular cone is able to detect quite a lot. And it pretty much tails off at around about 550. It's not able to detect anything at that point. And then the other cones have different ranges. So the green cone has a preferred wavelength of 500. I think that's 535. But it seems to actually, the green cone is able to detect all of the different wavelengths. So what happens is that when you're seeing light of, let's say, this wavelength here, 575, your eyes say, well, my blue cones are not detecting anything, or maybe your brain is saying, my blue cones are not detecting anything. My green cones are detecting something, and so are my red cones. And so they use that information with experience to translate it into a color. Okay, so our brain essentially invents something called color, and that's how we see these different wavelengths. So we think of it just as color, but really it's just our brain's representation of different wavelengths of light. And like I said, that's within particular frequencies. If we go beyond 400 or beyond 700, outside of this range, we don't see anything at all. But there is light there. It's just that we don't actually call it light, but it is essentially the same as light, but we just can't see it. In fact, if we look up here, we can see that there is loads and loads and loads of this tiny little sliver is the amount that we can see. But as you go further to the left, the wavelength's getting smaller, and further to the right, the wavelength's getting larger. So the wave might look like this over here, and over here it might look like this. And I'm not doing that to scale. It's much larger than what I've drawn, and it's much smaller than what I've drawn. But that is, and we can only really see this tiny little, what do you call it? Range. Sorry, range. If it was a little bit larger than red, we now call it infrared. Or if it's a little bit smaller than ultraviolet in terms of wavelength, a little bit smaller than blue or violet, we call it ultraviolet. And if it gets even smaller again, we call it X-rays. Even smaller again, we call it gamma rays. Actually, it turns out for these waves, which are called electromagnetic waves, so visible light is a type of electromagnetic wave, these waves can be quite damaging when they get quite small. When the wavelengths get smaller, the waves themselves have a lot more energy, and they can use that energy to do a lot of damage to the body. X-rays can be fairly harmful, and ultraviolets can be a little bit harmful. Visible light isn't really that harmful, and infrared and radio waves are even less harmful than that. So, but the point is, though, that these waves are all around us all the time. We just can't see them. We use radio waves we use our mobile phones to detect radio waves and microwaves, microwaves are basically, can be thought of as a type of radio wave. So that could be this bit here, this chunk here could be microwaves. Our phones use those, and we also use microwaves to cook our food on a microwave oven. Infrared is a type of electromagnetic radiation that anything gives off if it's a little bit warm. And you can also detect X-rays. Can be, well, we know that we use X-rays to see inside people's bodies, and ultraviolet is given out from the sun. But anyway, all these are there all the time. You can actually get a very cool little trick you can do. You can get a remote control and you can film it with your phone, and your phone will actually pick up the infrared and display it on the screen as if it was visible light. So this is a picture taken with a phone camera, or also with webcam. It could be with a webcam, of somebody pressing a button on a remote control. And if you looked at it, you wouldn't see any light coming out the remote control, but you do see it coming out when you film it on a camera, because the camera on these webcams or these phones actually detect a wavelength slightly larger than 700, and so it can detect infrared. Okay, so that's all I'm going to say about color and how we interpret it from different wavelengths into color in our brain.